Exponents are also called powers or indices. The exponent of a number says how many times to use the number in a multiplication. In this example, 8 squared is equal to 8 times 8, and that is equal to 64. In words, 8 squared could be called 8 to the second power, 8 to the power of 2, or simply 8 squared. So, an exponent saves us writing out lots of multiplies. In this example, a raised to 7 can be written as a times a times a times a times a times a times a, and also can be written as this form. Notice how we wrote the letter together to mean multiply. We will do that a lot here. Another example would be x raised to 6, and that is equal to x times x times x times x times x times x. Now, writing all the letters down is the key to understanding the laws. In this example, x squared times x cubed is equal to the quantity of x times x comes from the x squared times the quantity of x times x times x from the x cubed, and also can be written as this form. We have 5 x's here, and that is equivalent to x raised to 5, which shows that x squared times x cubed is equal to x to the 5th power. But more on that later. So when in doubt, just remember to write down all the letters, as many as the exponent tells you to, and see if you can make sense of it. In this part, all you need to know is the laws of exponents, also called rules of exponents, comes from 3 ideas. The first one is the exponent says how many times to use the number in a multiplication. The second one is a negative exponent means divide, because the opposite of multiplying is dividing. And the third one is a fractional exponent like 1 over n means to take the nth root, just like this form. If you understand those, then you understand exponents. And all the laws below are based on those ideas. Here are the laws of exponents. And in this table, you will see the laws of exponent with example. And furthermore, let us explain the first 3 laws above. The x raised to 1 equals x raised to 0 equals 1, and x raised to negative 1 equals 1 over x are just part of the natural sequence of exponents. Now, look at the table for a while. Notice that positive, 0, or negative exponents are really part of the same pattern. That is 5 times larger or 5 times smaller, depending on whether the exponents gets larger or smaller. Now, in the next law, with x raised to m times x raised to n, how many times do we end up multiplying x? The answer is first m times, then by another n times, for a total of m plus n times. For example, we have x to the second power times x to the third power. We all know that this example can be written as x times x comes from x squared. Then we have x times x times x comes from x cubed. And if we multiply x by itself 5 times, then we have x raised to 5. So, x squared times x cubed is equal to x to the power of 2 plus 3 equals x raised to 5. Now, we're going to talk about the law that x raised to m over x raised to n equals x raised to m minus n. Like the previous example, how many times do we end up multiplying x? The answer is m times. Then reduce that by n times because we are dividing for a total of m minus n times. For example, x to the 4th power over x to the 2nd power. That is equal to x times x times x times x in the numerator comes from x raised to 4. Then we have x times x comes from x raised to 2 in the denominator. And that is equal to x times x, or the remaining will be x raised to 2. So, x raised to 4 over x raised to 2 is equal to x to the power of 4 minus 2. And that is equal to x squared. Remember that x over x is equal to 1. So every time you see an x above the line and 1 below the line, you can cancel them out. This law can also show you why x raised to 0 is equal to 1. For example, x raised to 2 over x raised to 2. And that is equal to x to the power of 2 minus 2. And it will become x raised to 0, and the result is 1. Now, if we're going to talk about the law that x raised to m raised to n is equal to x raised to m times n, first, you multiply m times, then you have to do that n times for a total of m times n times. For example, the quantity of x raised to 3 raised to 4 can be written as x times x times x comes from x raised to 3 raised to 4 outside the parenthesis also can be written as this form. So we multiply x times x times x by itself 4 times. And if we combine them and if we count the number of x's here, then we have x raised to 12. So x raised to 3 raised to 4 is equal to x to the power of 3 times 4, which gives us x raised to 12. And now, what about the law that the quantity xy raised to n equals x raised to n times y raised to n? To show how this one works, just think of rearranging all the x's and y's as in this example. We have the given example, the quantity of xy raised to 3. It can be written as xy times xy times xy. And if we remove the parentheses, it goes like this. And the thing is, we will just rearrange the x's and y's. And we have this form. Then we will put parentheses on that. And we will count the number of x's. We have x cubed and the y, that is y cubed. And that is the final answer here. And as we proceed, the law that x over y raised to n equals x raised to n over y raised to n is similar to the previous example. Just rearrange the x's and y's here. For example, we have x over y raised to 3. And we will write x over y 3 times together. So we have x over y times x over y times x over y. Then we will rearrange the x's and y's. So we have x times x times x in the numerator over y times y times y in the denominator. Now, if we count the number of x and y in the numerator and denominator, we have x cubed over y cubed. And that will be our final solution here. Now, what about this law? Okay, this one is a little more complicated. I suggest you read or watch fractional exponents first, so this makes more sense. Anyway, the important idea is that x raised to 1 over n is equal to the nth root of x. And so, a fractional exponent like 4 raised to 3 over 2 is really saying to do a cube and a square root in any order. Just remember from fractions that m over n is equal to m times the quantity of 1 over n. For example, x raised to m over n is equal to x raised to m times 1 over n. Also, it can be written as x raised to m raised to 1 over n. And that is equal to nth root of x raised to m. The order does not matter, so it also works from m over n equals 1 over n times m. Let us have the same example, x raised to m over n equals to x raised to 1 over n times m. Also, it can be written as x raised to 1 over n raised to m. And the final form would be the same, nth root of x raised to m. And that's it. If you find it hard to remember all these rules, then remember this. You can work them out when you understand the 3 ideas near the top of this video. Oh, one more thing. What if x is equal to 0? When the exponent is positive, then 0 raised to n is equal to 0. And when the exponent is negative, 0 raised to negative n is undefined because dividing by 0 is undefined. And if the exponent is 0, so we have 0 raised to 0. And that is the strange case of 0 raised to 0. There are different arguments for the correct value of 0 raised to 0. 0 raised to 0 could be 1 or possibly 0, so some people say it is really indeterminate. You've come this far. I know you're a great learner, and your effort watching this video until the end is really exceptional. I hope we see you in our next quest because we will be using exponents in our next journey.